Okay, so now I would like to talk about flow control. This time we will talk about loops. So what are loops? We need to do some process repeatedly sometimes. So in order to write less lines in our programs, we can do loops. So here is an example. So bear in mind that this is not real Python syntax here. So if we want to collect data, for example, we want to collect data every day for a whole month, and we don't want to write the same process or the same lines again and again. And what we can do is that we just write the repeated process once only, and then we put it under a loop. So here is a loop. This is not real Python syntax, so I'm just showing you the idea here. So we want to collect data from day 0 to day big T here. So maybe we want to collect data for a whole month every day. So it's 30 times repeating the same process again and again. So in here we just write the repeated process once, and then we put it under this loop. So the program will know that they will do it one line by one line, and then at the end of this loop we'll go back to this line and then do the whole loop again. So your program knows that it needs to keep going back to this line until the small t equals to big T. So another thing we need to bear in mind is that your program will automatically increase the value of your small t here, which is like a counter in your loop. Okay, at the end of the first loop, your t will become 1. At first it would be 0, right? So at the end of the first loop, it will become 0. Oh, it will become 1, sorry. So, and then it goes back, and then until this small t increase to the value of big T here. So if we don't want to do loops, we'll have to do a program like this. We'll have to write many times for the same process, and then your program will be long and tedious. So a simple application in earth science is that we want to do some script, some process to the data over time and space, and then we need to do the same process, right, over different locations or over different time periods, and we don't want to repeatedly writing the same lines again and again. So this is like an application in earth science. Okay, so here is an example showing you how do we make use of a for loop. So for example, if we want to print the number 1 to 10, okay, so the output is in here. So if we don't want to write this print repeatedly, what we can do is that we can assign the values 1 to 10 to this SEQ, which stands for sequence, and then we do a for loop. We're telling the computer that this print line is under this for loop, okay? And then if this I is a dummy variable, so if this I is within the numbers in the sequence 1 to 10, we will have to execute this line. Okay, so I have a flow chart here. So your computer at first will do a checking. This is a hidden check. Your computer will check that if this I value is between the value of 1 to 10. Okay, if it's true, then it will go into the loop and then do the print statement here. And then there is another hidden thing here, which is an advancer. So your I will be increased by 1 to 2. Actually, you are jumping to the next value, which is 2, okay? And then you will do the checking again. If it's true, then this line is executed again. Okay, so this advancer will increase your value, or you advance to the next value until it is out of the range of 1 to 10. Then it will be false because it's not between 1 to 10. If it's 11, then you will leave this loop and then do the next steps following. Okay, so there is a way to avoid writing 1 to 10 here. If it's 1 to 10, then it's easy, right? But if it's 1 to 1000, then you are not going to type all the numbers, right? So what we can do is here is that we can use a function called range. This is not CUHK, this is range. Okay, so you can make use of the function called range, and if you are putting 1 and then 11 here, you are producing a sequence of values from 1 to 10. So 11 is not included in here. Remember, the last number is not included. So these two programs will produce the same results, which is lying in here. So this is the output. Okay, so the indented lines here, indented lines means there is a space here called indentation. So if you put an indentation here, which it means that your print statement is within the for loop, and then it will be repeated if your value is between 1 to 10. Okay, so here is just showing you inside each of the repetitions what your program is doing. So when I equals to 1, which is the first time it's looping, then you're printing 1, and so on and so forth. Okay, so here is an example a little bit complicated than the last one here. So what we're doing is that we want to do summation of 1 to 10. So we added a line here, t equals to t plus 1. So your value, for the first time you do the looping, I equals to 1, and then you print 1. And because t equals to 0 at first in here, okay, then 0 plus 1 is 1. And then this value t equals to 1 is carried to the next loop, okay? So next time you have 1 here, and then because I is 2, because this is the second time you're looping here. So 1 plus 2 is 3, and then so on and so forth. So basically you're adding 1 to 2 to 3 to 4, like this, and then at the end it's 55. So this thing, the symbol here is just showing you the part where we have indentation. Okay, it's under the for loop. So the part where we have indentation, we have 2 lines here. Okay. So we have made use of what we call a list here. This is a list. So we can store non-numeric data with a list. Right, like here, it is actually a list of strings. So Alice, Bob, Charlie, and Earth Warrior, these are names of people. Okay, so if we do this loop, we can do it with Visual Studio Code. Okay, new a file and then paste it here. Save. Okay, and then run Python file in terminal. Okay, you can see that your statement is executed repeatedly, 1, 2, 3, 4, because you have 4 values in your list here. So why is it important? Because sometimes we need to save information in terms of words. Okay, for example, here we want to store the names of different weather stations in Hong Kong. So we can put them in here. You can see that sometimes there are weird symbols in your string, right? So like here, Kings Park. So this is why we need a list of strings in here. Okay, maybe we can try this too. Save it. And then one Python file. Okay, so your statement is executed 4 times because you have 4 names for 4 stations. Okay, so sometimes we have to do nested loops. So what are nested loops? In here we have an example. So we have a loop. The dummy variable is I in here, and then we want to loop from 1 to 3. We are writing 3 plus 1 here so that we won't forget that this is only doing 1, 2, and 3, and 4 is excluded here. Okay, so the nested loop is in here. The dummy variable is j. Please don't use the same dummy variable as the for loop in here because there are 2 different loops. Okay, so this is looping from 7 to 8 only. 9 is excluded. Okay, so what we are doing here is that we want to print I, and then we want to print the value of j. So the output here is listed in here. Okay, so this is 1 when I equals to 1, and then you print j, 7, and 8. And then when I equals to 2, you also print j equals to 7 and 8. And then the same for I equals to 3. Okay, so this is showing you the flowchart of the nested loop. So when I equals to 1, it's starting from 1, right? And it's within this range, so it's true, so it's going inside. And then you have this loop 2 times because j has to be 7 and then 8. So 7 you loop 1 time, and then 8 you have to loop the second time. Okay, and then you escape this because it becomes 9. It's false, and then you advance to the next value for the outer loop. Okay, so that's why you're getting 7, 8, and then I equals to 2, 7, 8, and then I equals to 3, 7, 8. Okay, sometimes you can use the command break because you know that you no longer need to do the repetitions anymore. So here is an example showing you we want to end this loop when I equals to 13. So it's looping from 1 to 100. Remember, 101 is excluded. So you put the lines here, and then you want to check if your loop is having a break. So if it's not, then you advance to the next value. Okay, so we can try this in the Visual Studio Code. Okay. Okay, you can see that you have run this program, and then we are printing the current number is 1, 2, 3, 4, and then until 13, and then it's printing 13 is unlucky and abort, and we are out of the loop now. So why are we having this? Because your program goes into this part, the if structure. So it equal when it is equal to 13, we are printing this 13 is unlucky, and then we put a break here and we escape this whole loop. So we are going this way when your I equals to 13, and then we escape and we are no longer inside the loop anymore. We're out of the loop. Okay. So what if we move this line, the line with the star here, we move this line under this if structure, which is case 2 here. We can try it. Okay, so just copy and paste this line. Remember to use the right indentation. So we need 2 indentations here. Okay. Okay, we can run this program now. Run Python file in terminal. So it's not printing the numbers from 1 to 13 now. It's just printing 13 only. Okay, that's because we have moved this print statement under this if structure. So if it's only printing when it's equal to 13. Okay, that's why. So this is like a flow chart. We are moving the line with the star under the if structure, and that's why when it's looping from 1 to 12, it's not printing because it's not equal to 13, right? Okay, next we talk about while loop. In while loop, there is a major difference between the for loop, because in the for loop, this part is hidden. So the advancer, what do I mean by? Okay, so the advancer where you go from the current value to the next value, it's gone. Okay, it's not in the while loop. For loop, because it's a sequence of numbers, that's why your program knows the next value. Okay, and in while loop, it's not like that, because it's not a list of numbers. It's just one condition testing in here. So if x is not equal to 7, then you go into these 2 lines. Okay, this is like a checking, so which means that you need to update the value of x so that you can escape this while loop. So which means that you have to write this part to update the value of x, and in here, in this case, the update line would be x equals to x plus 1. Okay, so when you're inputting the value of 2, then x is not equal to 7, right? It's equals to 2. Then you go into this while loop, and then you print 2 in here, and then 2 plus 1 is 3, and then it keeps going back because it's not equal to 7, and then 3, and then 4, and then at the end 6, when 6 plus 1 is 7, and then it equals to 7, and this time is where you are escaping this while loop, because it equals to 7, then this conditional would be false. Okay, and then you escape and go on to print this dn in here. Okay, so there is another option here. You can also put an else in here. So an else is you're just adding one more step in here. When you're escaping this while loop, you are executing this statement. Print x is finally equal to 7 in here. So it's just the same, exactly the same as this program, but you are doing one more step in here. So that's why we are having this output. Okay. Okay, there is a possibility that your loop, your while loop is not ending. It's never going to end because sometimes your updater will not update the value until this condition is false. Okay, for example, if you're inputting an 8 in here for the value of x, then 8 is not equal to 7. Definitely it's not equal to 7. Then you add 1 to your 8, which is 9, and then you keep going back because x is just increasing and it will never reach the value of 7 in here because 8 is larger than 7, right? You just keep increasing the value and it will not go back to the value of 7. And what you need to do is that you are having an infinite loop, and what you need to do is that you need to press Control C in your computer to break the loop. Okay, I can try this in the Visual Studio Code. Okay, so can run this program. You see that there is no output and it's not ending. It just keeps increasing. Okay, so what you need to do is that you need to click this terminal area and then Control C, and you are interrupting the program instead of letting it end on its own. Okay, so next I would like you to do an exercise with the data provided here, which is a CSV file. Okay, so these are the average value from the HKO for mean pressure, daily maximum temperature, and mean temperature. So the question is asking you to do a moving average, which is a continuous calculation of mean previous data. Okay, how do we do that? So the 30-year moving average for the year 2000 would be the average value over this period, 1971 to 2000, 30 years in here. You average this and then you put the value back to the year 2000. Okay, and then you do the next, the year 1972 to 2001, that would be the 30-year moving average for the year 2001. Okay, so you can start with the code provided in here. It allows you to read the CSV file. Okay, the spreadsheet file. So here is also an example showing you how to get the column with this mean degrees Celsius, which is this one, column E, and then the year equals to 1961, which is this one. So this line, it will be giving you the value of 22.9 in here. Okay, so this is just an example showing you how to get the mean temperature in the year 1961. And you can try this on your own. Okay, so next exercise is asking you to write a loop so that we can do this sequence. We need to do a recursive loop. Okay, you need to add the value of the previous two values, and then you put it here. So 1 plus 1 is 2, and then 1 plus 2 is 3, and 2 plus 3 is 5, and so on and so forth. So we're asking you to provide the 30th and the 40th numbers. Okay, and then check that if they are divisible by 2, 3, 5, 7, and we have talked about this. Use the modulus operator we mentioned in the last lecture. Okay.